Right. So can you see my screen perfectly? So last class what we did force, we did field also. Properties of source charge, right. Then next topic is electrical lines of force, right? So just write down. These are imaginary lines which tells us about which tells us about the strength of electric field. So what do we mean by this? Let's say these are the electric lines of force in one region, and these are the electric fields of lines in another region, right? So we can say electric field is strong here, and since these lines are far apart, so electric field is weak. Now you got it. These lines tells us about the strength of electric field, and these are imaginary lines, right? So now we need to write what are properties of lines of force. Got my point? So first property is they emerge from positive charge and ends at negative charge, right? So that means the lines of force, they come out from positive charge and they get inside the negative charge, right? Second property is they do not form closed loops. Write down, they do not form closed loops. Actually what happens, they go from positive charge and ends at negative charge like this, but they never go back from negative charge to positive charge. So that means they do not form closed loops. Getting my point? Next, write down third property. The tangent to electric lines of force, the tangent to electric lines of force gives the direction of electric field. Have you got it? Now, one of the most important properties which normally comes in the exam, I'll tell you. No two electric lines of force intersect each other, because at this point the tangent to this line is this and the tangent to this line is this. So that means there are two directions of electric field, right? So let's say if a positive charge comes here, how it can decide whether I need to go in this direction or this direction? This is not possible. So that's why we can say two lines of force never intersect each other, right? Yes, if the two lines of two electrical lines of force, they never intersect each other. Right. So just write down two electrical lines of force never intersect each other, else there would have been two directions of electric field, which is not possible. Is it okay? Now comes the very important topic in physics, dipole. You must have heard about this word in your chemistry, right? Dipole is like we have HCl, so the electron pair shifts towards chlorine, right? Because it is more electronegative. So it gets partial negative charge and hydrogen gets partial positive charge due to the lack of negative charge, right? So here we get partial negative charge and here we get partial positive charge, which is same in magnitude. Is this clear? So there is some distance between the HCl, H and Cl, right? So this is called dipole. And in chemistry, you take the direction of the dipole from positive to negative. Is this very much clear? So direction is taken from positive to negative because dipole movement is a vector quantity, right? Now, in physics, this is a positive charge, this is a negative charge. It is separated by a certain distance. We call this distance 2a. Why 2a? Why we cannot say a? Because all the distances are measured from the center of the dipole. तो अगर क्या होएगा कि अगर हमें सारा डिस्टेंस सेंटर ऑफ डायपोल से मेजर करना है तो हमें बार बार a/2 लिखना पड़ेगा इसे. Then it will be confusing. So simply just in order to avoid confusion, we call it 2a. It's not necessary. You can call it a, you can call it l, you can call it r. But normally we call it 2a. I've told you why we call it 2a. Is this fine? Right. So we just call it 2a so that in order to avoid the confusion. Got it? This is, so write down the definition of the dipole. Just make this diagram and write down the definition of dipole. It is a system of two equal and opposite charges It is a system of two equal and opposite charges separated by a distance two-way. Is this fine? Now, the line which is along the axis of dipole, this is called axial line. Is this clear? The line which is perpendicular to this dipole and passing through the center of dipole, this is called equatorial line. Is this very much clear? So just write down axial line. Write down axial line. The line passing through the axis of dipole is called axial line, right? The line which is perpendicular, now write down equatorial line. The line passing through the center of the dipole and perpendicular to it is called equatorial line. Is this clear? So now you understand the axial line and the equatorial line, right? So now let's say, what actually is dipole? It's nothing but two charges, positive charge and negative charge. And whenever there is charge, it always creates electric field, right? So this is one of the most important derivation which we are just going to do. See, there is a proper, you don't have to learn derivations. The thing is, you have to understand how to write a derivation. It's a technique. Simply you have to write a derivation in a very simple manner. It's very, very simple to write derivation. I'll tell you the proper technique of writing the derivation so that you get full out of full marks in derivations, right? Because in theory you have to write in such a way that you always get full marks, right? So let's say, first of all, the main thing about the derivation is you have to make a proper labeled diagram like this. This is a dipole. We call this point A. We call this point B. This is the center of the dipole. Let's say this is point P at which we have to find electric field due to dipole. What we are trying to do is, just write down the heading, electric field on axial line electric field on axial line due to dipole. So basically at point P we have to find the electric field, right? So let's say this distance is R, that is from point P to the center of the dipole. We call this distance R. This is half length of dipole, which is A. So this distance becomes R minus A. And this distance becomes R plus A. Right? We know electric field is a vector quantity. Let's say E1 is the electric field due to positive charge. Mark this. Okay. So just write down E1 here. E1 is equal to electric field due to positive charge going on the left hand side like this. And E2 is the electric field which is going on the right, which is due to negative charge. Have you got it now? Yes, E1 and E2 are two electric fields we need to calculate because the net electric field is E1 minus E2. That I'll tell you. Means the two charges will create two electric fields. Positive charge will create E1 and negative charges will create E2. If they are equal, then the net electric field will be 0. If E1 is greater, there will be net electric field in the direction of E1. Are you getting my point? So just make this diagram, then we'll move ahead. Have you understood the diagram properly? Great. Yes. Absolutely, because the electric field of the negative charge will go towards it, and for the positive charge, it goes away from it, like this. For positive charge, it goes like this. Great. So this is the, you have to adopt this strategy. Yes, you have to adopt this strategy for all the derivations. That is, make a proper diagram, and then you need to think what you have like assumed, like E1 is electric. That will just write. You have made this diagram properly, right? Now write down. Consider a dipole with positive charge kept at A and negative charge kept at B. Let P, next line, let P be the point at which we have to find electric field. Have you got it? Yes. Now write down E1 is the electric field due to positive charge, and E2 is electric field due to negative charge. Got it? Now vector E is equal to vector E1 minus vector E2. Yes, we will just see, we'll just check. Write down. Now we'll calculate E1 first. So formula for electric field is KQ by R square. R here is R minus A whole square, and vector E2 is equal to KQ upon R plus A whole square. So vector E, this shows magnitude because the distance is different. Although charges are same, but the distances are different, right? Is this okay? So now we need to solve it. KQ Got it? Have you got it now? Now, finally, we have got kq into 4ar upon r square minus a square. Right till here. Right. So now, see, when we are talking about dipole, the length of the dipole is very less. Because as I've given you the example in HCl, it's a molecule. So the distance between H and Cl is very, very less. So we can neglect this distance. Are you getting my point? So write down in the next line after this, since it is an ideal dipole, therefore a square can be neglected. Is this okay? So ultimately, what we have got here,